Should I begin? 1 minute? Okay. Is it okay? All right. Welcome to this session about streams and collectors in action. I don't have much slides. This will be mostly live coding. You all know that Java 8 is all about lambda expressions and streams, and this is what we're going to see now in these quick sessions. This session the goal of this session is to, in fact, answer two fundamental questions in computer science. The first one is how good at Scrabble Shakespeare would have been. And we're going to see that. I'm José. I work at the University of Paris 13. I also contribute to various open source developer code, and I work as an independent. I have a blog, mostly in French. If you have any question or reaction or comments or whatever, or insult, you can use this hashtag. Great. And this is the GitHub account on which all the code I'm going to play now is available. So what do we have here? We have, in fact, two files. This is basic stream code. We have two files here. Maybe I should take this one. In this file, I have all the words Shakespeare used in his book. And in this other file, I have all the words available in Scrabble. Let us have a look at that. There are roughly 24,000 words for Shakespeare and 80,000 words for the Scrabble. And if you go and check Wikipedia, this is the score of each letter of the Scrabble. Well, the English version. Personally, I use the French version mostly, but there's also an English version of the Scrabble game, as you might know. So how are we going to do that? First, we need the score function. So this is a lambda expression. All right. This function takes a string, which is a word, and will return an integer, which is the score of that word at the Scrabble game. I call it function score. It takes a word. I've got a nice method on the string class, which is the chars method. It builds a stream on the letter of that stream of character. I can map that stream by transforming the letter into its score, by reading the array I just showed you, and using this old trick to read the correct cell of the array, and then sum it up to have the score of the letter. Now, once I have this function, I can take the words of Shakespeare, build a stream on that, and collect them using the correct collector, which is the grouping by collector. I collect by score, so the keys of the HashMap build will be the score of the words. And then we're just going to begin by counting the words with that given score. The result is a HashMap. What is this HashMap? The keys are the scores, so they are integers, and the values are the number of the words, the amount of words used by Shakespeare that have that score. I can print out this HashMap to see what it gives. Okay, so I know that there are 2,000 words for 10 points. And if I check at the top of it, I've got 2 words for 40 points. Now I can just change this code to watch those words. Let's collect, not by counting, but this time in the list. It's no longer of map with long values in it, but it's a map still of integer and list of string. This list will show me the words. Okay, and I'm not interested in all the words. I'm only interested in the word with the score of 40, so I can filter this stream, and I will keep the word is the score applied to the given word is, let's say, greater than 39. So if I do it like that, I can see that I've got two winning words. I don't know if everybody can see this. Honorificability something. Okay, some French that have got problems to read that kind of word. And Nebuchadnezzar. So I'm not a Scrabble champion, but I know that this word would not fit on a Scrabble board just because it's too big. The Scrabble board is not that big. So in fact, I need to add another filter here and to retain only the words that are contained in the Scrabble dictionary. So the Scrabble word should contain that word. Okay, so this is not right anymore. Let's comment that out. Let's count again to see how is our map is made of now. What are the best scores? Okay, the best scores are 29 and 33. So let's filter out 29, so 28 here. Let's have a look at those words. Let's take the list again here. Great. So the words are whizzing and buzzards. Now there's a little problem in those words is that I have got two Z's, in fact. And there is a common thing between the French Scrabble and the English Scrabble is that I have only one Z in the little bag with the little letters in it. So how can I handle that? In fact, I can write this name, this word, but I need to consider that the second Z is a blank. And this has first an impact on the filtering method, that I can accept a word if I'm okay to use two blanks, because I've got two blanks in the Scrabble. And it has also an impact on the computation of the score, because the second Z will score 0, since it is a blank. So what's funny is that it turns out to still be a map filter reduce problem. First, I need a function that will take a word, and I'm going to build the histogram of the letters of that word. That is a map of integers. Those are the letters, and of long. Those are the numbers of this given letter in that word. And I'm going to call this method letter histo. So I take a word, still the chars. Then I need to map that to an object, because the chars is an int stream, so it's not a stream of object, just by passing the new method of the integer class. And then I will collect that in a collector, grouping by. Grouping by the letters is fine, so the key is just function, identity. And I just want to count the letters, so it's the collector counting again for the value of the maps. Is this correct? It's not, it doesn't compile. Oh my God. I'm sorry. I'm so long, integer new. Okay, so it's not a string here. It's an integer. No, sorry, it's a string. Cars, map too long, integer new. Map to obj, sorry. Okay, that's it. So this is my letter, my histograms are associated to a given word. Now, from that, I can create another function which takes a word and will return a score, so and the number of blanks. I'm going to call this function nBlanks, and it will compute the number of blanks I need to use to write this given word at the Scrabble. So first, I'll build the histogram of those words, apply word, so this is a map. From this map, I'll take the entry set, because I can't build stream directly on maps. It's not possible. It's not in the API yet, maybe. Maybe we'll have that one day. Entry set, so on that stream, on that entry set, I'll build the stream. And I'll map that to a long to be able to sum it up, because on the map to long, well, on the long stream, on the stream of numbers, I've got a sum method. And now what do I need in this map to long? I need to compute the number of blank letters I want to use to write that word. So I need to compare, basically, the entry. So this is an entry, a stream of entries. The entry dot get value, which is the number of this letter I need to use to write this word, minus the number of letters effectively available in the Scrabble game. So this is the Scrabble. I've got another array for that. Scrabble and distribution, and I need to pass to read the right value, so it's entry.getKey minus A, same trick as above. Then if I need, for instance, 2z, entry.getValue will be 2. And I've got only one z available, so this will be 2 minus 1, this is 1. So I need to take the long dot max of 0 and this value, oops, and this value, and this is the number of blank letters I need to use to write this word. Now I need to change the way I compute the score, because now I don't want to, the score of the blank is 0. So I need another function. I'll copy paste this. This function will be score2. The score is an integer. So later I build the histogram for this word. It's a map to integer this time because a score is a score of integer. And what I'm going to do the same thing here, that is sum up the result. And what do I need to compare this time? The entry.getValue, this is the number of letter, let's say z, available, I need to write in my word. And this is the number of letters available in a Scrabble, in the little bag. So what I need to take is the mean of those two things, because of course I don't want to use more letter than available in the Scrabble, in the little Scrabble bag. Okay. Mean value. Now entry.getValue is a long, so I need to take the long value of that. Sorry. It's a lambda expression. Don't forget about that. So I need entry.getValue. This is a long. So I need to take the long value of that and to cast it to an int, since I need it to for the Java code. Map to int, did I say? And that's it. All right, oops, sorry. So now what do I need to do? I need to change this. Of course, this is going to be score2 here instead of score1. I need to add the filtering. I need to filter for the words that need more than 2 blanks to be used. And blanks apply word. So this has to be lesser or equal than 2, because this is the number of blanks I have in my Scrabble game. Collect grouping by to list. This is fine. I'm going to use the counting once again. So this is the given map. I forgot to do something here, is that here I need to multiply by the score of the given letter, because here I just count the number of letters of the given letters to write that word. So I need to multiply by the Scrabble EN score, which is basically the same as the previous one, entry.getKey minus A. All right. Let's see what it gives. So I've got two scores, 25 and 26. So now I can, let's say, filter this like that and watch those words. So the words this time are Jezebel, quickly, and squeezes. Those are the best words in the Shakespeare literature that you can write at the Scrabble game and that you can put on the board. Another second fundamental question of computer science is, would Dickens be better than Shakespeare at the Scrabble game? So I also have all the words used by Dickens in his literature. And ladies and gents, I can tell you that Dickens would have beaten Shakespeare by 1 point and using this word, squeezed with a D, because the D is 2 points, where the S is only 1 point. Well done, Dickens. Okay, this is a quickie, so this was really quick. You can check out the code here. And if you want to know what would have been the score of Shakespeare if he had put his word